Fiber optic cable is a cable that uses electrical signals for communication. Fiber optic is a cable that holds the optical fibers coated in plastic that are used to send the data by pulses of light. The plastic coating protects the optical fibers from heat, cold, electromagnetic interference from other types of wiring. Fiber optics provide faster data transmission than copper wires. Basic elements of fiber optic cable. Core. The optical fiber consists of a narrow strand of glass or plastic known as a core. A core is a light transmission area of the fiber. The more the area of the core, the more light will be transmitted into the fiber. Cladding. The concentric layer of glass is known as cladding. The main functionality of the cladding is to provide the lower refractive index at the core interface as to cause the reflection within the core so that the light waves are transmitted through the fiber. Jacket. The protective coating consisting of plastic is known as a jacket. The main purpose of a jacket is to preserve the fiber strength, absorb shock, and extra fiber protection. Following are the advantages of fiber optic cable over copper. Greater bandwidth. The fiber optic cable provides more bandwidth as compared to copper. Therefore, the fiber optic carries more data as compared to copper cable. Faster speed. Fiber optic cable carries the data in the form of light. This allows the fiber optic cable to carry the signals at a higher speed. Longer distances. The fiber optic cable carries the data at a longer distance as compared to copper cable. Better reliability. The fiber optic cable is more reliable than the copper cable, as it is immune to any temperature changes, while it can cause obstruct in the connectivity of copper cable. Thinner and sturdier. Fiber optic cable is thinner and lighter in weight, so it can withstand more pull pressure than copper cable. Applications of fiber optic cable often found in backbone networks, because its wide bandwidth is cost-effective. Some cable TV companies use a combination of optical fiber and coaxial cable, thus creating a hybrid network. Local area networks such as 100 base FX network and 1000 base X also use fiber optic cable. 2. Unguided transmission. An unguided transmission transmits the electromagnetic waves without using any physical medium. It is also known as wireless transmission. In unguided media, air is the media through which the electromagnetic energy can flow easily. Signals are normally broadcast through free space, and thus are available to anyone who has a device capable of receiving them. Propagation modes. Ground propagation. In this, radio waves travel through the lowest portion of the atmosphere, hugging the Earth. These low-frequency signals emanate in all directions from the transmitting antenna and follow the curvature of the planet. Sky propagation. In this, higher-frequency radio waves radiate upward into the ionosphere where they are reflected to Earth. This type of transmission allows for greater distances with lower output power. Line-of-sight propagation. In this type, very high-frequency signals are transmitted in straight lines directly from antenna to antenna. Unguided transmission is broadly classified into 3 categories. 2.1. Radio waves. Radio waves are the electromagnetic waves that are transmitted in all the directions of free space. Radio waves are omnidirectional, i.e., the signals are propagated in all the directions. The range and frequencies of radio waves is from 3 kHz to 300 GHz. In the case of radio waves, the sending and receiving antenna are not aligned, i.e., the wave sent by the sending antenna can be received by any receiving antenna. An example of the radio wave is FM radio. Omnidirectional antenna for radio waves. Radio waves use omnidirectional antennas that send out signals in all directions. Applications of radio waves. A radio wave is useful for multicasting, when there is one sender and many receivers. An FM radio, television, cordless phones are examples of a radio wave. Advantages of radio transmission. Radio transmission is mainly used for wide area networks and mobile cellular phones. Radio waves cover a large area, and they can penetrate the walls. Radio transmission provides a higher transmission rate. 2.2. Microwaves. Electromagnetic waves having frequencies between 1 and 300 GHz are called microwaves. Microwaves are unidirectional. When an antenna transmits microwaves, they can be narrowly focused. This means that the sending and receiving antennas need to be aligned. The unidirectional property has an obvious advantage. A pair of antennas can be aligned without interfering with another pair of aligned antennas. The following describes some characteristics of microwaves propagation. Microwave propagation is line of sight. Since the towers with the mounted antennas need to be in direct sight of each other, towers that are far apart need to be very tall. Very high-frequency microwaves cannot penetrate walls. This characteristic can be a disadvantage if receivers are inside the buildings. The microwave band is relatively wide, almost 299 GHz. Therefore, wider subbands can be assigned and a high data rate is possible. Use of certain portions of the band requires permission from authorities. Unidirectional antenna for microwaves. Microwaves need unidirectional antennas that send out signals in one direction. Two types of antennas are used for microwave communications: parabolic dish and horn. A parabolic antenna works as a funnel, catching a wide range of waves and directing them to a common point. In this way, more of the signal is recovered than would be possible with a single-point receiver. A horn antenna looks like a gigantic scoop. Outgoing transmissions are broadcast up a stem and deflected outward in a series of narrow parallel beams by the curved head. Received transmissions are collected by the scooped shape of the horn, in a manner similar to the parabolic dish, and are deflected down into the stem. Applications of microwaves. Microwaves, due to their unidirectional properties, are very useful when unicast, one-to-one, communication is needed between the sender and the receiver. They are used in cellular phones, satellite networks, and wireless LANs. Microwaves are of two types. A. Terrestrial microwave transmission. Terrestrial microwave transmission is a technology that transmits the focused beam of a radio signal from one ground-based microwave transmission antenna to another. Microwaves are the electromagnetic waves having the frequency in the range from 1 GHz to 1000 GHz. Microwaves are unidirectional as the sending and receiving antenna is to be aligned, i.e., the waves sent by the sending antenna are narrowly focused. In this case, antennas are mounted on the towers to send a beam to another antenna, which is km away. It works on the line of sight transmission, i.e., the antennas mounted on the towers are the direct side of each other. Characteristics of microwave frequency range. The frequency range of terrestrial microwave is from 4 to 6 GHz to 21 to 23 GHz. Bandwidth. It supports the bandwidth from 1 to 10 megabits per second. Short distance. It is inexpensive for short distance. Long distance. It is expensive as it requires a higher tower for a longer distance. Attenuation. Attenuation means loss of signal. It is affected by environmental conditions and antenna size. Advantages of microwave. Microwave transmission is cheaper than using cables. It is free from land acquisition, as it does not require any land for the installation of cables. Microwave transmission provides an easy communication in terrains, as the installation of cable in terrain is quite a difficult task. Communication over oceans can be achieved by using microwave transmission. Disadvantages of microwave transmission. Eavesdropping. Eavesdropping creates insecure communication. Any malicious user can catch the signal in the air by using its own antenna. Out-of-phase signal. A signal can be moved out of phase by using microwave transmission. Susceptible to weather condition. A microwave transmission is susceptible to weather condition. This means that any environmental change such as rain, wind can distort the signal. Bandwidth limited. Allocation of bandwidth is limited in the case of microwave transmission. B. Satellite microwave communication. A satellite is a physical object that revolves around the Earth at a known height. Satellite communication is more reliable nowadays, as it offers more flexibility than cable and fiber optic systems. We can communicate with any point on the globe by using satellite communication. How does satellite work? The satellite accepts the signal that is transmitted from the Earth station, and it amplifies the signal. The amplified signal is retransmitted to another Earth station. Advantages of satellite microwave communication. The coverage area of a satellite microwave is more than the terrestrial microwave. The transmission cost of the satellite is independent of the distance from the center of the coverage area. Satellite communication is used in mobile and wireless communication applications. It is easy to install. It is used in a wide variety of applications such as weather forecasting, radio/TV signal broadcasting, mobile communication, etc.